Welcome to TechbrothersIT. In this video, we are going to learn about approxQuantile. ApproxQuantile gives you approximate value for quantiles or percentiles. It is faster than exact quantiles and works well on big data set. From the name you can tell approx, so it is approximate, so that helps to calculate a little quicker when you will be using with the big data sets. So here's the syntax. You have a df and then you say approxQuantile and then a column probabilities and the relative error. So the column you want to calculate quantiles on, probabilities a list of the quantiles you want, such as 0.5 for median, so, and you can go 0.25, 75, 0.75 as well. So it depends whatever the values you would like to see for your quantiles. And the relative error, allow error is equal to 0, exact but slower. So let's take a look on the relative error. Lower relative error, more accurate but slower. So if you are looking for more accurate data, then you have to provide a small value for your relative error. If you will provide a higher relative error value, then less accurate but faster. So that's that's going to happen. Now let's take a look on the sample data, and here is our sample data. We have we have ID, name and age, and here we are creating a data frame called the df. Once the data frame is created, what we are going to do, we are going to use that in our demo and see how the approxQuantile work. Now our data is created and data frame is created, and we can see the data as well. So you have Amir and then Ali Raza and then different ages for them. So that's great. Now we will go with the very first example. Get the median 50th percentile. Okay, if you want to do that, how you do it. So here I will provide this data frame equal to df dot approxQuantile age, that's my column, and then 0.5 that's 50th percentile, and then 0.01 in the error. So that's very small, like it's 1%, and once I run it, so it's going to print a median age from the data frame. So let's go ahead and execute, and it's brought us the result, say 30. Now what we are going to do, if we want to go for the 25th, 50th and 75 percentile, so in this case we will say df dot approxQuantile and then age, and here we will provide those probabilities 25, 0.5, 0.75, and same relative error. Still I kept the 0.01, that's 1%, so that's fine. And now we go ahead and execute this one, and it's going to return us all those values. So we go back here, and here see the 25th, 50th and 75th percentiles, and this is a 28 value. So that's a 25th percentile, that's the value for that one. And for 50th percentile we are seeing 30, that's the age, and for 75 percentile we are seeing 40. Now if I want to go further ahead and right here, now in this case you have get min, so 0th, and then for median 50th, and for max 100th percentile. So you can do that as well. So that's easy to do. Now we will execute this, and then we'll go from there. So you can see min, median and max. So you can see 25 is the min age, 30th is the median age, and then 50th is the max age. And here in this example, still we are doing set relative error to 0.1, that's less accurate but faster. Okay, and here in all above example we were using 0.01, and here we are doing 0.1, so that's the difference. And now I'm using on the age, and then 25th percentile, median, or 50th percentile, and 75th percentile, but I just change the relative error to 0.1 instead of 0.01. So let's execute this one first and see the results. Okay, so here is the results, and you see quantiles with high relative errors 25, that's for the 0th and 25th percentile, then we have 28, and then we have 35. So It is if you, right now this doesn't really make sense because you have very small data set, and but it works when you have a large data set, then whatever the number you will set higher relative error, then it's gonna depend, like if you will set to higher or lower, then it can take more time or less time depending on the value you have set. So approxQuantile is useful when you need to quick estimate of quantiles or percentiles. Works well on large data sets because it is fast. Relative error let you control the speed versus accuracy trade-off. So you can play with your data set and see the size of your data set, and then see if you want more accurate results or you are okay with the approximate results, and then you change the value of your relative error. Thank you very much for watching. Please subscribe my channel, and I will see you guys in the next video.